All right, welcome to another walkthrough video on Tryhackme. This one's That's the Ticket. Uh, it's a pretty interesting little web application where users can create accounts, submit tickets, and then admins check on those tickets. I think this is a really cool application to kind of see how stored cross-site scripting can be bad and even with some protections in place. So we'll jump into the app and I'll show off those very particular parts of the application. So this is a more of a challenge room. It's not guided or anything like that, but it does have some hints in here that really define what you need to think about while you're doing this room. So it starts off with just saying that IT support is going to have a really bad day, but don't think they're stupid. They have really strict firewalls. Using the IT support panel, try to make your way into the admin account. Hint, our HTTP and DNS logging tool on this IP address will come in useful. So we'll go ahead and pull that up. And when we look at this, it's a request catcher. It creates a unique URL that you can use on the Tryhackme private network for logging HTTP and DNS request. So Burp does this too, but Burp would do it into like an internet accessible host, and uh, you you wouldn't basically be able to catch that, is what this is kind of saying. So when you create this session, it gives you this basically DNS name here, and what this is that if anything calls out to this DNS, it will log it and show it here um, as a way to kind of let you know what's going on. So let's start our normal processes. So we're going to go ahead and copy the IP address. We'll echo that out into our targets folder, our targets text targets.txt. And then we'll go ahead and start our nmap scans. So we're going to do -il. We'll let that do that one. Kill some of this other scripting scans there. So that's going to be the detailed one. And we'll go ahead and get the basic one going too. All right, so that scan's going, and we'll have to do sudo for the top one. So the initial scan immediately picks up port 22 and 80. Detailed, looks like it's going to find definitely those two. It's going to start a service scan on there. So, we again, we can go into our normal reconnaissance here. We can run dirbuster. We're going to need that IP address. So we'll want to save this. So we're going -o output and go buster results.txt. We're seeing a lot of 302s, size 0. So it looks like this website's just going to take anything that we send to it and kind of redirect it. So we can verify that by going to it and seeing what that looks like. So we'll copy this out. We'll go here. Okay, we definitely get the ticket manager, but let's just see. Yeah, so it just keeps redirecting to the same page. So GoBuster here is not going to help us without specifying something a little bit different. So that's not going to help us out. So let's look at this page then. Again, we can start looking at the page source, see if there's any hidden comments or anything like that. We do see that we're loading some local libraries there, jQuery and Bootstrap, but everything else is just normal. They are doing some integrity checking. So if you don't know what um, this is verifying that this script is this hash whenever it's loaded. And if it's not, then it will not load that hash. It will not load that script. So that's something that you definitely want to happen if you're loading stuff from an external resource. In this case, they're loading it from the server resource, so it's not a big deal. It's still, a little extra security. But if I'm loading something from jQuery.com that's hosting the jQuery JS, then I would want to have that integrity there, because if jQuery changed, I would not want that script to load because I haven't checked it, I haven't validated it, right? Um, and that's really just going to depend on the business justification. So, in a pen test finding, I would maybe flag these two scripts as not having the integrity and make it a low finding, and just provide that to them, because again, they're loading external scripts that do stuff to their page without checking it. In this case, again, like I said, they're loading it from their local server, so not a big deal. But if this was a completely different server, not theirs, then definitely a big deal, because we've had a lot of supply chain attacks very similar to that. So we have two functions. We have a login and we have a register. Login's asking for an email and password. So we'll do test. Let's see if we can just log in, maybe try an admin. Don't mind that count there. So, we don't have a particular account on this box, so we can try to register. Will it let us register one? We'll do test, test, and test, and then test and test. Okay, so we can register account. We do see we have like a login section over here. We have no tickets created. We can leave a message, just some kind of IT ticket manager. So if we write something on this and create a ticket, we now have a ticket ID. So there's a ticket ID too. So another thing I would do in this web application is I would try multiple ticket IDs up here and see if I would get access to anything else. Just in that case, they're not doing any checks. That'd be basically an IDOR, or indirect object reference. So you could have the possibility of reading other tickets without that. So we could just try that real quick, but we're not seeing anything else. So the next section about this is that we know this is a ticket manager and we know someone else is reading this. So we want to see then if this application is doing any filtering, and if it's preventing any cross-site scripting, basically in this instance. We'll finish up. Let's look at the scans real quick before we get in that. So nothing on the SSH. We're running Nginx, and there's some older vulnerabilities with Nginx there, 2019, 2018. More likely not going to be any of that stuff, and that's it. So nothing additional from the scans there. So with your first test, you can just go blank, with the script, and can I do alert 1, and then can I exit the script, create a ticket, and we see that we are definitely having our stuff back in the box, but it's not changed, right? And so what I usually like to do on these web applications like this then is I'll look to see what am I looking at in this area, okay? And so our text is hitting this text area here. And with the text area, anything saved in that area ends up just being text. So what we can try to do is fake this out and close that HTML tag and then insert our script after that. And you'll be surprised that this works on a lot of different places, because what happens is um, the the place that it's hitting it now ends up being closed, and you're basically adding that script after there. So let me put that in there and I'll show you what this looks like. So if we do a slash text area, right, we're closing that HTML tag, and now we can put in what we were doing before. And success. So what happened here? What was different between these two, right? So if we look back in this element here, see what I did is exactly this. I closed that text area right there. That's mine, and then there's my script that I added right after that. And so that basically gives you uh, a way to kind of load cross-site scripting in there, and load any JavaScript to be to be run on the page. This is also stored because when we go back and we can click on this ticket, it happens every time. So that's a stored cross-site scripting instead of reflective. Reflective is if I just did this attack and all it did was show it one time and that was it, and I'd have to get someone to kind of look at that. Also notice again that we're generating these numbers up here for tickets, and so we will want to keep an eye on that as we play around with this stuff and try different numbers later on. When we, spoiler alert, when we get to the administrative side, we can look at those ticket numbers and verify that we could maybe even access those without having to have logged in or logged in directly. Another way that we can verify that is if we need to actually log in, is if we take this ticket number and we just go to a new private window. And now again, we don't have a session, so it does redirect us. So we don't have a complete IDAR. We'd have to have at least an authenticated IDAR. So you have to be authenticated, but we'll see if we can read the admin tickets when we get there. Okay, so we have the ability to do cross-site scripting. So the biggest thing with stored cross-site scripting is you want to usually steal the cookies, right? The way that you authenticate the sites ends up storing that information into a cookie, and so we want to steal those session cookies. So what I'm clicking on here is the storage, and then under storage you'll have your cookies, and on the website is the cookies, and then there's the name of the cookie. So this one is called token. There's my session ID basically. So pretty long, pretty random. It's not something I'm just going to easily guess or brute force, right? That's another good thing to kind of look at, is because if I can, if this is token 1, then what happens if I put in token 0 or token 2 or token 3? So that's some ways that people do authentication and they don't do it correctly. So you want this to be a long number, somewhat random. Um, not easily guessable, things like that. So, okay, we're good on that cookie, right? We see that it is linked to this website. The path is for the main path. It doesn't expire until next, tomorrow. And then here's the kicker, right? Is that this cookie is not available via HTTP only. So only the website can load that cookie. We're not going to be able to get that. So what I'm meaning by this? In regular JavaScript, if I open up the console here, you can access the document, and everything in JavaScript is related to objects. So document.cookie would normally list out whatever cookies it has if it wasn't like HTTP only. So because that's HTTP only, and we're requesting this cookie value, then you're just going to get back blank every time, and that's the reason when you're doing these web pen tests that if you're looking to make sure that the cookie value has HTTP only. Um, that's the reasoning for that is I as a JavaScript cannot access that cookie value. It has to be done on the back end to validate the session. So I'm not able to read that cookie value, but there's other things I can look at on this page, right? We do have our username up here, what we logged in as, and that'll give us something. So how do we read this? How do we get to that portion there? Um, so knowing a little bit about web programming again kind of helps you understand what you can do with the objects on the page. So in this case here, we're seeing that this is a span and it has an ID, and the ID is this email, right? And so with Java, again, everything is related to the document. So we can query the document, okay? And so that's the whole page. This is everything so far, right? And we need to narrow that down. Um, and one of the ways that we can do that is we can get an element by its ID name, okay? And this was given to us by loading in those additional JavaScripts. So the get element ID is part of jQuery, if I remember correctly, and it allows you to ask for specific things by like IDs or by the tags or anything like that. So we could ask for the body, we could ask for class, and then have it equal navbar, or again ID navbar. And what it's doing is it's pulling that information straight from the document that way. So in this case, what we want is we want the email. And so as you can see, as I'm typing, it's getting stuff. And so uh, it's gotten the email there, right? It's pulled the HTML tag, but we need the inner portion of that. We don't need the tag. We need what's inside. So when you put inner.html, now you see we're getting that test at test.com. And so now we're right there. Like we have the email address. So so we can load this into some kind of script and have that sent to us. But again, knowing how web applications work, certain things like ands and dots are special characters, and that ends up being issues. But we at least have an idea now that we can play with JavaScript in here. We could get some of this stuff that way, and that would probably be the best way to kind of do that, right? All right, so let's also try. Let's also try to see, well, maybe the user, the admin logs in and that works too, right? We know that we can load JavaScript, and maybe we can take control over their browser. So one of the older packages that I don't really see a lot being used as often anymore, but it's still really good, it's still up to date, is called the Browser Exploitation Framework. And you'll have to install this on the newer versions of Kali. But Beef is really cool because if you have cross-site scripting, what it allows you to do is add in a JavaScript hook, and then that hook is controlled by your browser now. Now, I'm going to show this off, and I'll go ahead and preface it that this isn't going to work because of the firewalls in place, but I'll be able to give you a little idea of what you could do because of I can show it being ran on my system. What it does is it spins up this service and it's listening on port 3000. And what we can then do is we can go to our panel and we can look at Beef here. Okay. And I've already set this up. So whenever you first install it, it'll ask you to set up a new user for it. And this is it here. So the way to basically hook a browser is to have it load in that JavaScript that it says right here, this IP 3000 hook.js, okay? So in our case, it's going to be, my IP address, and in your case, it's going to be whatever your IP address is. All right, so we're going to do the same thing. Create the ticket, text area. Okay, and then we need to put our IP address in there. So again, that's going to change based on whoever you are. So 10 to 12 to 19. So I thought this would be cooler if they allowed this to work. I I see what they're getting at though. I see how this room was set up, and that's still pretty cool though. So if we look at beef here, what'll happen is we should get, there it is. So if this was the admin's browser, which it's not, it's my browser. If at any time they go look at those tickets, here's all the capabilities of the browser, so you can see exactly what they're able to do. There's the logs. Here's commands that you can run in the browser. So again, beef, it has this hook. As long as that person's on that page, this JavaScript's running, and you can do all these different cool things like get the cookie. So again, it's not going to be able to get the cookie because of HTTP only. It's able to get the beef hook cookie, but that's the only one because that's what got done. That's what got is available, basically accessible to it. And the way that we can again look at that is if I go in here and I go look at storage and we see cookies, we can see HTTP only is at false, and that's why we can read that cookie now. So that's again why it's very important that those token cookies are always HTTP only. But we can also read other information here, like we could read form values. So again, I'm just clicking that and I click execute. Couldn't find any input fields. How about whatever links are on the page? We could execute that. So there's links on the page. They basically linked out to the login, the logout page, any HTML. So you get the whole HTML if you wanted to. So I think this would have been really cool if you could have done load this, because I look that was the first thought in my process of doing this, and when I got beef to actually run, I was like, oh cool. But then when I saw that it's right here, test.com. Let's make that bigger. So let me find it. Where is it at? There it is. So that's how I knew that I was only hooking myself and I hadn't hooked anybody else. Again, any of these other browsers would come online too, but it's good to kind of know and understand how this works, because again, if you do get this opportunity where you could hook somebody with beef, then that's even better because you have more control over their browser. You can do, you know, you can fingerprint the browser. You can get again local storage, which this is all the storage in that site. So again, there's nothing right now. Session, any stored credentials. That's not going to work, but can detect extensions. So if they have any extensions on their browser, it's a really cool way to kind of learn more about whoever you know visited the page. So you can specify URLs to see if they visited certain URLs. Any Chrome extensions, you can do DNS tunneling. That's of course not going to work or anything. There's exploits. So again, if they had like a router or switch or something on the other side of whatever they're accessing, that's the way that you would use their browser against them to do that. We can see if that works. Very powerful. Very very much a way to kind of control a browser and determine more about that. Again, the big thing is that the user has to stay on that page during the whole time. So in that instance, it might not work. You could create another invisible iframe and keep that, or do like a persistence and keep a way in there, like a man in the browser. So that way, if it changes or anything like that, then you're still on there. Anyways, all right. So again, that's a small introduction to beef. Would have been really cool, a really neat way to kind of show off, how to use beef. But in this instance, we're not getting the beef hook back, and we'll get into why exactly. Okay, so we know that we're able to do JavaScript, but we're not getting something coming back to us. If we were able to get something back to us, then it would have it would have loaded that beef hook. We would have saw the browser at some point. Even if it was offline, like if it just briefly visited us, it would load the JavaScript and then gone offline. So this is where that request catcher kind of comes in play. And what we need to do is we need the admin's browser to request a DNS in that space so that we can know what data that they were trying to request. Okay, right? And the way that we're going to do that is that we're going to do an encoding of their request. And again, we have all this access via the JavaScript, so that's probably the best way to kind of to use it is to have JavaScript take that data and then encode it and then ask for that domain name. Uh, and if it does that, then we can, we're capturing that data, so we're able to pull that out and then be able to use that as what it was looking up. So let me find the script real quick. All right. Looking for this script. That's all right. All right, so we'll just have it directly query something. So we put the script in here and then we'll call it out. All right, so can I drag that bigger? Thank you. All right, so we're open up the console here and we'll hash everything out. So similar to what we did before, document get element ID, enter HTML. So then the next command there is split. And what we're splitting on is going to be the @ symbol. And so we're putting the @ symbol there because that's not a usable character within a DNS name or so. You'll see now that we split that, right, we have two arrays. We have a 0 and a 1. So 0 gets assigned to email first, and then email second gets assigned to the second location. Then what we need to do is change that script to our host here, this one here. Right there. All right, so what we're building is we're calling HTTP localhost dot the first, which in the case currently is going to be test dot test.com dot 4fb yada 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 tech and then test, and then so it's saving that as an href, and then the JavaScript's going to call it for a new image and make that source equal that reference. And so dynamically on the page, what we're doing is we're creating an image and then for the source to that image is going to be that DNS. And because it's going to reach out to that DNS, it should get caught here because this is basically listening to anything on uh, above this domain or higher, basically. So any subdomains or subdomains, because we're already three down. So anything past that, if that makes sense. So let's submit this ticket. We'll create that ticket. Okay. Oh, I totally messed up. I did not include the first close. So we're going to have to redo that. Got to close that ticket out, or close that text area. All right, so now, yeah, so now we shouldn't see it. So if we go back to our catcher, now we see all these different requests, right? And we can start at the bottom. So we see localhost admin account .it support .thm. So that's the admin account making a DNS name request out. And then there's another request for just the main domain. There's test at test.com. That's us. Another test.test, and then there's the HTTP request. And again, we see that this is from us, not from anybody else. So seeing this, what this is telling me is that the system allows DNS request out, but it's not allowing an HTTP request out of that environment. So they have a firewall on the outgoing connections going out, and again, that's a more secure environment. They might even have it, in a corporate environment, they might have a proxy, an outgoing proxy. So then that would come from a different address. So it would try to hide, where it's coming from exactly. So the big portion here that we care about, right, is that we got the admin account at IT support THM. All right, so that's what we're going to copy. And you saw that a little bit earlier whenever I was trying to log in. So, okay, so we're going to log out, log back in, and we'll try this person's account. But now we don't know the password, right? So we could try some generic ones like test or admin. So we're not getting that. So what we need to do now is we need to just pound a bunch of passwords at this thing and see what comes out, right? So to do that, we need to understand how these requests are being made. So I'm just going over to the network tag. I'm looking at post, and then over here in the inspector is that you can look at the request. And so we're just making form data. So it's just a post request with the email account and then a password. All right. So feel free to use whatever brute forcing tool that you want to. You could use burp and just specify that at the password you're going to try a word list. I'm going to use Hydra, and I'm going to use Hydra because it's just a little bit more robust there. So we're going to go ahead and shut down beef since we're not going to use it. Like I said, if you can find a stored cross-site scripting vulnerability in a web application and it's not using the HTTP only as the cookie, again, that's a really cool way to kind of show the risk to the environment. And even if it's using HTTP only, it's a way to show why that stored cross-site scripting is important to fix, because I've seen some environments where management says, well, we don't really care because you can't steal the cookie. You can be like, no, now I can control people's browsers. So, and that's the way to show them. All right, so for Hydra, we're going to need to remember that this says invalid email whenever we do incorrectly. And then we're going to craft up the Hydra command. I'm going to pull it straight off my history because, again, Hydra's a big pain. but it's great when it does work. So apparently I don't have it, so that's fine. All right, so Hydra, we're going to do -L for the login name, and that's going to be that account. Okay. And then we want it to -P, big P. So that's going to brute force that, and we need to give it a word list. So we're giving it user share word list RockU. And then the next thing is the IP address. So what IP address is it going to talk to? And just the IP address. You don't put HTTP here. Okay. All right. Then after that is the method that it's going to do. We're going to have it do an HTTP post form. Then you need to give it the location. So that was login. And then after login, you're going to give it the parameters that it's going to do. So in the parameters, what we see here is email equals the username and password equals the one that we want to test. So it's going to be equal and then user, and that's how you annotate what to replace there. And then password is going to be equals pass. And then what was the invalid response? So how does it know that it's failing, and how does it know it's passing? So we're just going to do this right here. All right. All right. So really quickly, it found admin account at IT support, worked with 123, 123. So if we go back to the form, put that in, we log in, we're able to see that now. So we do see that these tickets are numerical order. So it does have some ability to verify that these tickets are not readable by any other user, because again, we had tickets that were 1, 2, 3, and 4. So it is looking at the session ID or whatever that is. So we've gotten, all right, so we gotten that. So let's answer some of these. We do have this one now. Okay. Same here. All right, and for the final thing, we just need to find the flag in ticket 1. Let's go back to the application there. So there's that. Okay. So that's the box there. Again, we could go back and see these other tickets, see if these are any of our tickets that came in. Yep, it looks like they are. So ticket 1 looks like the one that we would have started out with. So we can access that here. If we did, again, let's try. Say, so this was test. So again, we do start off with ticket 2, so can we access ticket 1 directly? And we cannot. So it is preventing you from reading the tickets that you didn't, create, or if you're not admin for. But But that's something that you should definitely test on a web application. So again, I have an admin account, I have a user account. Can I read that other data? Because some web applications, all they care about is that you're authenticated. That's it, right? And so that would have been a big, like privilege escalation or some kind of leak or something like that, where it definitely flagged that as a finding that if I could have read that. But in this case, we can't, so that's fine. That's a big, no big deal there. But yeah, that's the box. Again, really cool, cross-site scripting stored. Again, it would have been really cool to kind of let you maybe capture the cookie from the admin, but these are modern applications and mitigations that are in place. So having the HTTP only, cool idea. Like a good way to kind of prevent you from just getting the cookie and going that route. Making you kind of query JavaScript to get whatever the username was to even brute force. But yeah, I would have liked to maybe have used B for something similar to kind of do a little bit more, pull a little bit more data. Um, but still really cool box, still really cool way to show you the power of a stored cross-site scripting. So I hope you enjoyed it, hope you learned something, and I'll catch you in the next one.